Welcome to another OSU CyberLab video. This video illustrates a number of cyber-relevant tools from class. The voiceover was generated using Clipchamp text-to-speech to speed production and present diverse voices across videos in the collection. The other lab materials provide background and explanations to help you learn from what we do here. In short, we will explore a scenario where a vendor is allowed superuser access to a web server in our simulated network. Weak configuration leads to having the password file exfiltrated and cracked. Start by connecting to the lab environment and starting the needed VMs. Navigate to the L drive. Double-click on the scan Webserver Lab 2024 batch file. Click Run when asked. This executes a script that configures and starts needed lab elements. Press Enter twice to respond with a Y when asked about reconfiguring the network interfaces on the Windows host. The command shell closes when the script is finished. You may notice that 3 virtual machines are now running. Next, we use nmap, a widely used utility, to reach into the simulated network and see what ports are open in the web server. Remember, never do this kind of thing on an organization's network unless specifically authorized. We start by setting the computer to default to the Windows Terminal app for opening command shells. Search for and click on Settings. Type Console into the Settings search box. A pull-down menu appears. Click on Terminal Settings. You will see a pull-down in the Terminal section that says Let Windows Decide. Change that setting to Windows Terminal. Then exit Settings. Search for and open the Terminal app. Type in the provided nmap command to look for open ports at the web server's address. You will see 2 ports. SSH on port 22 is closed. HTTP on port 80 is open. Next, we will add an account for our hypothetical vendor. They will need root access to maintain the web server. Navigate to the Hyper-V window. Then connect to the ecom VM. Choose a resolution that works for your setup. Sign on using the provided username and password. Click on the terminal application to open a command console shell. You may be able to copy commands from the instructions to the shell. It depends on the settings on your device. But you can always type. Use the add user command with sudo rights to create a webmaster account. When you run a superuser or sudo command, you may be asked for the sudo password. If so, the isadmin01 password is adminpass. You are asked for a password for the new user. Enter the provided password. Twice. We will skip adding additional directory information for the user by pressing Enter for most questions. When it asks if the information is correct, enter a Y. Using the provided command, add the webmaster to the sudo group. Members of this group can execute superuser commands. Now create a .ssh folder in the webmaster's home folder. We will use this folder later in the exercise. Add a second user called webmaster2. Give it the very bad password abc123. Having this weak password will mean our cracking tool will make one match promptly, so we don't have to wait too long to see how it works. SSH is widely used to open command shells on remote computers. In our scenario, the new webmaster needs remote access to the ecom server. We will allow password-only authentication. This is probably not a good idea. But even if stronger authentication were configured, the later parts of the lab are still possible if the vendor's device were to be compromised. Recall that port 22 for SSH was closed when we scanned it earlier in the lab. Let's change that. First, we run a command to check the status of the SSH service. It had been a few minutes since we ran a superuser command, so it asked us for the password again. It shows that the service is inactive. Ctrl-C will exit the display. Now use the provided command to start the SSH service. If you press the up arrow, previous commands will appear. Press the arrow twice to recall the command to recheck the status of the service. This time, the service is active. As before, Ctrl-C exits the display. If we navigate back to the command shell on the Windows machine and use the up arrow to recall the map command and press enter, we get a different scan result. This machine, which is outside our simulated network, now reports that when it scans our web server it sees SSH as open on the standard SSH port, number 22. Now we are going to provision password-only SSH access to the web server. This involves changing the text of a configuration, aka config, file. The SSH service reads in configuration details when it starts up. Lines in the config file that start with a hashtag are ignored. Use the change directory, cd, command, to navigate to the directory that contains the sshd config file. It is in etc ssh. The ls command lists the files in the folder. The sudo edit command has been set up to open privileged files in the gedit text editor. Open sshd config. You can ignore the extra slash characters in the video, my finger slipped. Navigate down to line 57 in the file and add a hashtag at the front. Before making this change, password-only authentication was forbidden. By commenting out this configuration instruction, SSH defaults are applied. By default, password-only authentication is allowed. Save and close the file. The change does not take effect until we restart SSH. Restarting makes the service reread the config details from the file. When it restarts, the setting change will take effect. We have now provisioned a webmaster user with sudo rights and remote access. What could happen if the webmaster's device and account are compromised? The attacker could enter commands on a remote shell to copy the password files, change restrictions on those files, and copy them out to another device outside the network. Navigate back to the Windows machine, remembering it is outside the simulated network. The current window is a local window that executes commands on the Windows machine. We didn't need to clear the window, but we did. Use the SSH command to open a remote shell. This will be like getting access to the keyboard and monitor of the machine you connect to. The provided command tells the Windows machine to run an SSH client program with the provided user and the machine as identified. Remote connections are potentially tricky business. Once you connect to a particular machine at a particular address, your client remembers some details. Enter the password for the Webmaster user account. When you log in, some information about the target machine is presented. Don't worry that this one has not been recently patched, this machine is only used in the lab. We clear the screen to avoid distraction. You are now executing commands on the ecom server. First, we will use the Webmaster's superdoer rights to make copies of the password files in a different folder. These files are protected. Not just anyone can change them, and they can't be copied off to a remote device. Unless of course you are a super user who can override those protections. If copy/paste is working for you, you can copy the commands from the instructions, click into the shell window, right-click, and choose paste. But typing them works too. The command is cp for copy. Then path name of the source file and the path name of the target file are entered. The sudo password for the Webmaster is needed to execute these copies. 2 files are needed. Oversimplifying, one lists the users, the other contains the password hashes. Next we use the change owner, chown, command to make the Webmaster the owner of the copied files. This will allow them to be exfiltrated. The up arrow comes in handy. The instructions don't require it. But, in the video, we navigate to the folder that has the copies and list them. p.text and s.text. The shell we are in executes on the ecom server. Open a new terminal window using the plus sign. This one will execute commands on the Windows machine. The scp secure copy command is used to copy in files from a remote server. After scp, you type in the user and server address, a colon, and the path name of the file to be copied. Then you enter the path into which the file is to be copied on the local machine. The tilde refers to the home folder of the user. In this case we are getting the file from the .ssh subfile in the home folder of the Webmaster user. The user's password is required. Both the p.text and s.text files need to be exfiltrated if we want to crack the passwords. Next we will use John the Ripper to crack the stolen passwords. Staying in the same shell that executes on the Windows machine, navigate to the BIS files folder where we stashed the stolen files. Execute the provided shadow command to combine the two files. Note that the programs are in the John the Ripper run directory. Next, convert the new file to UTF-8 encoding using a command from the PowerShell language. This is a hard one to type correctly, so copy and paste it if you can. And finally, execute the John program to start guessing passwords. You can look up how it works. It employs dictionaries to try to guess weaker passwords first. Like the shadow program, the John program is in the run subdirectory. Okay. It started. It will take some time to get going and find a match. There it is. It cracked the Webmaster 2 password. The has of the value it tried matched the has it found in the stolen file. Pressing enter would show progress. Control-C makes it stop. You'd have to leave it running a while before harder passwords are cracked.